Let's talk about policies, right? Now, most of you, you're on KyvernoCon. You're familiar with Kyverno, right? Or I hope so. Now, if I ask you what are policies, you're probably going to say, that's Kyverno stuff running in my cluster, right? That's what our policies are, but they're not, right? Those are not policies. Those are technical implementation of some business rules or business needs or guidelines or best practices that you have in your company, right? The real policies are those definitions, right? Your policies are most likely in English language or whichever language you're using, right? They are business requirements or the best practices that you have in your company. And then we later get to Kyverno policies. And Kyverno policies are extremely important for this story, but that's not where the story starts. And the reason is why it's not where the story starts is that if you start with something like technical implementation of policies like Kyverno, then what are the people in your company going to do, right? Are they going to read or go to the cluster, execute kube control, get cluster policies, read each one of them and figure out what they should do? Probably not, right? If you do, then we are hiring if there is such a person, right? What is most likely going to happen is that you're going to try to use brute force into your cluster, right? You're going to write some definitions, some manifests for an application or a database. You're going to execute kube control apply or use Argo CD or whatever you're doing. You're going to see that it doesn't work because it's rejected and it's good. And then you're going to fix it. And then you're going to do it again, and it's not going to work again, and then you're going to repeat that cycle over and over again until you finally pass all the policies that you don't know what they are, right? A better way should be that you actually get informed about your company policies, right? And we're going to get to that, right? So far, Kubernetes policies are similar to this bouncer at the door of the club, right? You come to the club, you say, I want to come in, and he says, man, no, you need to wear a tie. And I say, but nobody told me that I should wear a tie. Yeah, I'm so sorry, but kind of no tie, you're not entering, go back home, change your clothes, come back in, right? That's the last line of defense, and we have to have that. We have to have that bouncer at the door that doesn't allow anybody to enter who doesn't comply with whatever rules the club has. But it would be really, really, really nice if somebody informed you about those rules, about those policies in advance, right? So that's where AI comes in as well, right? So if you AI behaves in a very similar way as a person, right? It has certain knowledge, right? It knows certain things. It probably knows everything that was ever published on the internet. And then you tell it, hey, I would like to do this. And AI will do the same dance that I explained before. It will generate Kubernetes manifest for you. You're going to review it. You're going to say it's fine. You're going to apply it. Kyverno is going to reject it. It's going to change it. Apply, reject, apply, reject, brute force until it finally succeeds. What we really need to figure out, both with people and with AI, is where are all those policies really, right? They are in Slack, they are in wiki pages, they are in Zoom calls. A lot of policies in your company exist only in Zoom calls, in recordings of those Zoom calls, where somebody was discussing something and decided that from now on we should deploy our stuff only in US East 1 in AWS, right? And then finally, when you figure out how do we get all the information stored in random places, how do we extract all that information, and then how do we create the last line of defense? That's what Kubernetes policies are. They are not a way for you to know how to do the right thing. They're a way to prevent you from doing the wrong thing, which is very, very different. So for this talk, I actually created a very quick demo to show you how that looks like. And before I show you how that looks like, I will not have time to go through, analyze all my wiki pages and Slack documents and stuff like that. You need to imagine that that works. I'm going to focus on extracting what is in my head and nowhere else. And before I do that, there is a fundamental problem with Kubernetes if you're trying to use it with AI. etcd is horrible. Absolutely bloody horrible, right? You cannot inform, you cannot tell AI, or a human even, hey, go to my cluster and figure out and extract all the knowledge from it, because it's not designed for that, right? You cannot really do semantic search. You cannot do anything similar. So what I'm going to do is that I'm going to actually do the demo first, and then I'm going to explain to you how all that looks like, right? This is my Cloud Code. Everybody familiar with Cloud Code? Probably, hopefully. Cool. Everybody, like 2 of you. The rest of you, I don't know what's going on. Create a policy, right? So I'm going to try to teach AI how something works. I'm instructing it to create a policy. I'm going to copy from here because I'm too lazy to write. No, use MCP. Let's see whether it works. It's a demo. It's likely not going to work. There we go. Now it's going to walk me through some workflow and ask me certain questions like, hey, please describe what is the policy intent that you want to do, and the policy intent is this one. Hey, in my company, when we use GCP, we only use this region for databases. In AWS, only this region. In Azure, only this region, right? This is not technical implementation in any form of way right now. This is just the business rule. We decided that in AWS, we always use this region. Just a plain explanation in English. Then it's going to ask me, okay, what does this rule apply to? This is the explanation you gave me. Tell me what it applies to. I'm going to say to databases in Google and AWS and Azure, which is cool. Then it's going to give me some suggestions. And now this is the important part. It's going to give me suggestions of all the keywords that can somehow apply to this policy, right? And the important part here is because I'm going to pass it through embeddings and store it in a vector database, because I must assume that there are hundreds or thousands or tens of thousands of policies in a company, right? You might not be aware of it, but there are, right? And neither people nor AI can go through it all and understand it all at once, especially that AI has amnesia, by the way. The moment you finish working on something, it forgets everything you did, so it needs to be taught every single time. So I'm going to create some, I instructed it to create some keywords, to suggest some keywords through which we can find this policy when the time comes, and I'm going to say, yeah, all of those are fine. What else? It's almost finished, I promise. Why is this policy important for you? Write it for me, because I don't want to deal with that. I'm not allowed to say that word, so sorry for that. Anyway, it wrote actually decent when I read it. Ensures consistent data resilience across all cloud providers, blah, 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 blah. My team is in charge of that. And there we go. It will now create a policy. Now, 2 things will happen. And 2 things are absolutely necessary for that. First, it will store a policy in a way that is searchable, just like Google is searchable, right? So that both you and AI can find the policy. Say, give me all the policies related to databases so that I understand what I need to do. Or give me all the policies related to AWS, and so on and so forth. And the second thing it will do is that it will create the actual Kyverno policy in a cluster, simply because we need that last line of defense. So if you don't read the memo, you will be denied access. That will be that bouncer at the door. What is it asking me? What namespaces? Yes, A team, B team. I have those 2 namespaces in my cluster. Come on, come on, come on. There we go. Now it will work, work, work. Now, what is happening behind the scenes while the challenge I had when I was preparing the demo is, okay, so I want AI to not only store the information in a vector database, I want AI to generate actual Kyverno policies, right? And that proved to be harder than I thought for a simple reason, because it's very hard to discover what are all the things in your Kubernetes cluster, right? You can do kube control API endpoints, and then go through each of them, get the schema for each of them, analyze the schema for each of them, figure out which ones apply and which ones don't apply to your intent. It's a mess. It can take hours easily on my cluster. And so what I did before this session, I actually loaded whole etcd into a vector database. And what it's doing right now, it is searching through the Kubernetes resources definitions that I have in my cluster, and trying to decide from those approximately 1,000 different definitions, which ones are somehow related to what I just wrote. And what I just wrote is that our databases should run in US East 1, something like that, right? So it is trying to combine those to find all the resources that are somehow related, and then create and generate all the Kyverno policies for me, right? I will say, show me raw YAML of the policy. Let's see what it created, right? Let's see whether it works. Come on. Struggling. Who knows? Maybe. There we go. Kyverno policies. It analyzed a bunch of things, and it realized that, hey, there is something called SQL GCP Upbound. There is something called SQL GCP Upbound something else. And there is something called RDS for AWS provider. I want the policy to create an update. And those two namespaces and the policies should allow only creation of that resource from if the value of the region field is US East 1. And the same thing for the other RDS and force AWS, no, what is this one? And so on and so forth. A bunch of resources, probably some 20, 30 resources. It found which one of those are out of 1,000. It got the schema, generated the policies, and I can apply it to the cluster, or I can save it to a vector database, or both. I actually did both in advance. And now I'm going to show you how that changes everything when actually working. So imagine that my cluster already has a bunch of, let me skip this. It has a lot of information stored in a vector database, all the business rules, and it has all the Kyverno policies that prevent me from doing the wrong thing if I forget to read the information. The goal of this talk is that Kyverno might never be used in my company, and that's the ideal situation. You should have it, but it never ends up being used, meaning that neither per person nor AI ever tries to do something that violates the policy, right? That's the ideal situation. Your policies are never violated. So we're going to try to do something like this. I'm going to instruct AI and say, you know what? Let's start from scratch. Create a database for me. Let's see whether it will figure out what are all the policies and all the rules related to it. What should I be? It should be publicly accessible DB in AWS. What should make it PostgreSQL? What else? RDS, managed DB. Sounds good. That's my final wish. I'm spitballing here. Now, what it will do, it will spend a bit of time trying to figure it all out, because there are many, literally, around 1,000 different resources in my cluster. It's a medium-sized cluster. I'm going to skip all that, and I'm going to show you I executed the same result before. And it gave me suggestions. It says, you can create Azure PostgreSQL Actually, earlier I said Azure. Now I tried AWS. Imagine that I didn't show you that. Anyways, it's suggested for Azure, for example, you can combine resource group and server and database and firewall rule, or there is a second solution, there is a third solution. The third solution, for example, uses my cross-plane composition called SQL that matches all the needs, and I will tell it to do 3. Now, this is where the policies come in. Let me show you. Let's see. Come on. Now, what is happening behind the scenes is that I made the choice. I said Azure, blah, 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 whatever not. And it will go to the database and search all the policies in that database through semantic search that is somehow related to this. And it came up with this solution. You should tell me the database name. You should tell me the namespace. You should tell me the cloud provider. And this is required by the policy. Now, this is not that right now, Kyverno. It's just semantic search through the database of all the related policies and database size. And I'm going to say, let's say, MyDB to A-team 3, what did I say? Azure, and for small, I don't know, whatever small means. It will come up with more questions. And I'm just hoping that I will hit the thing that I did earlier. Let's see. Come on, come on, come on. It is asking me for version. Skip, doesn't matter. Anyways, earlier you saw that one of the questions was enforced by the policy, which is a knowledge base, like that I have to specify the provider. And another will be probably region. Let's see whether that happens. Skip. Anyway, this is all driven by policies that are in my cluster. Yes, yes. I want to show you the final solution because that part is important. Almost there. So it asked me a bunch of So it asked me a bunch of questions, applied my answers to the policies. When I say policies, I don't mean Kyverno. I mean policies in the database, the business logic that I have in the database, and it generated a simple manifest over there anytime soon now. There we go, right? And now I can say apply it, right? Deploy immediately, no. Yeah, let's say save it to tmp something.yaml, right? I blame Wi-Fi. There we go. There's my, you cannot see anything here, right? Let me increase the, still nothing. If you don't see it because it's not well contrast, you will need to trust me. Anyways, it created my manifests. Those manifests follow the policies, and if I apply them right now, execute kube control apply, they should hopefully namespace, A-team, apply the file name, this one. It works, right? And it works, and it didn't violate any of the policies simply because it knew in advance what is the right way to do it. If I say code, there we go, change the region to US West 1. I think that's how it's called in Azure. Maybe, let's see. No, remind me later. Kyverno kicks in, right? So the whole goal, know in advance what is the good thing to do, what is the bad thing to do, never get to this moment, but if you do get to this moment, then Kyverno will prevent you from doing the wrong thing. And the only way how to get there is through semantic search. I tried infinite number of combinations to teach AI what is the good thing, what is the wrong thing. It never ever works unless it can actually search through the database by itself. What else can I show you? No, that's my quick demo. Any questions? Boo. No? 5. I have 5 minutes for questions. I finished too early. Nobody? OK. There is one.
How do you export etc database to vector-less?
Oh, good question. So the question is, I'll repeat it just. How did they export etcd to vector database? So I have a process that discovers all the stuff in etcd, especially all the API endpoints, gets the schema for each of them, then uses AI to extract the things that matter in that schema, because schemas tend to be huge. I want to reduce to kind of what are the few sentences that actually are important regarding this resource. The goal is really to find out through the schema what the resource does, because the names are often misleading. I have, for example, CRD called SQL, but that's actually PostgreSQL, but you can figure it out somehow from the schema description and so on and so forth, right? So get the schema, extract relevant information, summarize it in a way, then create embeddings. Embeddings are the easiest part of the whole story. Store it in a vector database and then repeat for every cluster. Like 1,000 resources, it takes approximately 1 hour maybe, something like that, right? And the most of the time is actually spent either dealing with etcd, because it's actually very, very slow, or converting schema into meaningful keywords that matter later, right? And once it's over there, then basically, if you search for anything like, hey, give me all the resources related to AWS MySQL, it will find it. Or at least it will find not necessarily only those, it will find others, but most of the time it ranks them correctly. So you know that top 5 are probably the ones that you're looking for. Anybody else? Go for it.
Can you say a little about your MCP implementation? Where is it from? What does it do?
Oh, so MCP, that's my pet project, where I experiment with things. So basically, it's AI agent mixed with code, so that write operations are always performed by code, but then read operations are done by agent, like examine the cluster to figure out this and that. So it's actually, it's not, most people would not call it MCP, would call it agent. It's very specialized agent for certain tasks, like scanning capabilities of a cluster, managing policies, creating solutions like the one in the last demo. It's just that I don't believe that A2A works, agent-to-agent communication, at least not from Claude Code. So actually, I've wrapped my agent in MCP mostly to enable easy access to that agent from other agents. It's just a protocol, right? It can. It's actually, it's an agent that works through MCP, works through HTTP as well, and soon with A2A, because those are just wrappers. But it's a custom agent. Do I use other tools?
AI coding tools, it's not just Cloud Code, I assume.
Yeah, so it works with any tool you want, because it's MCP, precisely. Now, I personally stopped using anything but Claude Code for last maybe half a year. I was a big cursor user. I really disliked the idea of Claude Code, and then I got used to it, and now I cannot do anything else. My brain got rewired that it's actually, I'm more productive in a terminal-based agent than IDE-based agent. So I want terminal-based agent. That's the reason Claude Code. I tried others like what's the name? OpenAI or something like that. I tried the one from Charm. I tried Cursor CLI. They're all bad compared to Claude Code. So I'm mostly using Claude Code because there is no better alternative. And it's awesome. And it sucks that it doesn't work with other models. That's my biggest problem with Claude Code. Am I finished? Do I have more time? More questions? I see 0. That's the ranking I'm getting from for this talk. Thank you so much.